Will we soon be delivering power wirelessly to NASA robots on the moon? Hello and welcome to TechFirst. My name is John Koetsier. We're all pretty used to wireless charging by now. We charge our phones, we charge our smartwatches, any other tech that we have, we charge wirelessly, and that's fairly common. NASA, however, has just awarded a small tech company in New York a contract to develop wireless charging solutions for autonomous vehicles on the moon. Pretty cool. It's likely related to the massive Artemis project, and it will vastly expand robotic and human exploration of the moon. To chat, we have the CEO of the company that won the contract, Josh Yank. Welcome, Josh.
Thank you very much for having me today, and pleasure to tell you more and connect.
Awesome. Looking forward to it. Tell us about the project. You're developing wireless power for the moon. Sounds pretty cool.
So definitely an exciting development to do in conjunction with NASA, and for us as a company, kind of like our intro to start doing more space applications. Essentially, these kinds of contracts NASA awards to small businesses that they're looking to solve particular problems. And like you mentioned, NASA's like mandate on doing a lot of things relative to the moon with the Artemis missions has really put a lot of focus on trying to build out that lunar economy and trying to partner with small businesses, especially to really solve very difficult and I guess you could say niche kind of problems. One of them being, how do you actually charge these robots that are automated? You could think of the moon as a pretty dirty factory setting where in a factory, it's really hard to reliably power the robots on an automated basis because sometimes you get dust and dirt that covers the contact terminals, for example. So that's compounded even more on the moon. So we want to make sure that it's sustainable, that it's reliable, and the best way to do that is through a wireless charging interface, essentially.
It's pretty interesting you mentioned dirty and dusty. I seem to recall many of the astronauts who actually landed on the moon had huge issues with the moon dust that would cling to them, static cling, basically, right? And try and get rid of it as they went through the airlock. Super fine dust, super gets into everything, coats everything, and I could see that having huge challenges for connections that need to actually interface and connect.
Yeah, exactly. That's actually one of the biggest challenges. So it's the lunar regolith as well as the lunar temperature cycles, radiation exposure, but in particular, it's essentially the dirty and dusty environment that makes these mechanical connections very, very difficult, especially over a period of time, right? If I want to be able to operate something for not just a week, not just 100 days, but more than that, it makes repeated mechanical connections, regardless of what those are, very difficult to do, essentially. That's where we thought we'd be able to kind of make it really interesting niche there because we've been working more on factory settings on Earth, but we see a lot of these problems compounded in this kind of environment.
I had to laugh when you're talking about the mechanical connections because we've all had those charging cords for iPhones or Android smartphones that are falling apart, right? And they're cracking and they're just they can't handle it over time. And I can just imagine what's happening to anything that needs to connect when it's in, like you said, solar radiation that is just streaming in. There's no magnetic field to keep it at bay. Massive temperature ranges from super hot to super cold, and lunar day, lunar night, all that stuff. Talk about how it works and kind of how far is it going to be? Is something going to have to be really close? Can you do it over distance?
Yeah, so actually, a lot of what we like to focus on is I don't like to move the company to doing research for the sake of research, but really do our research for practical commercial products. So we're actually basing a lot of our space specifications off of upcoming, like let's say, lunar rovers, for example, the NASA Viper. So it's over a distance of over 15 centimeters. We're likely going to be targeting close to around 25 because that tends to be about the size of the vertical clearance for a lot of the average larger rovers that NASA is focusing on right now.
So it's going to be sort of a docking solution of some sort. It comes into range, it stays there, it charges up and it goes. Is like long range charging like continuous or semi continuous? Is that kind of science fiction still?
I guess it depends what you mean by long range. Like, how long are we talking?
Uh 10 meters.
Yeah, so that would be definitely a different type of technology for sure. For that kind of application, you have its own kind of challenges, but in particular, relative to the amounts of power that we're talking about, which for this embodiment is really closer to that kilowatt kind of range. Then
Mhm,
you have things potentially getting pretty dangerous, doing things like RF harvesting, or it could interfere with other kinds of either beings or signals.
mhm,
So we're focusing more on what's called near field technology. So that's much longer wavelength, so we could pack in that power a lot safer.
mhm.
So that tends to be, you could think about it as like a little bit more of a closer range in general. We're able to extend that more than, let's say, a traditional charging pad through some of our own developments. But in general, it's typically within about, I would say, half a meter or so.
Interesting. One of the challenges with a lot of lot of charging systems that are just, "Hey, place it on the pad and let it charge," that sort of thing. Heat. What about your system?
Yeah, so charging pads or in particular like cheese solutions are what's called inductive systems. So we do resonant inductive. They're kind of like cousins. But one of the big significant differences is we're exciting or resonating the coils at a higher operating frequency. And they tend to be what's called high intrinsic quality coils.
Mhm,
So that's high Q coils. That's it, basically a measurement of intrinsic efficiency of the coils. So it's a dimensionless parameter. It's inductive reactance over resistance. The higher the number, the better you can think of it in general perform. For inductive applications, these coils tend to be multiple overlapping coils that aren't very efficient. They typically have Q factors, maybe around like 50. What
mhm.
we've done, for example, with some of our automotive developments, could be above 1,000. So it's an order of magnitude more efficient. So you don't necessarily have the same kind of thermal buildup for those coils themselves, which tend to be more problematic for inductive applications. And you could also more significantly extend the range, for example.
Can you please talk to Tesla? My phone has gotten so hot charging in my Model Y that it has basically said I'm not charging anymore. I'm stopping. I'm too hot. So that would be good.
Yeah, it's actually funny. Like, there's a lot of back and forth too between OEMs and phone manufacturers. People like Apple, for example, that have like the MagSafe ring, which tends to then couple with the inductive solution and exacerbates the thermal issue because it was built for a different protocol at that time. So there's a little bit of a catch up typically when you deal with auto because it's usually around like 5 to 7 years to build and design a car. And the smartphone carriers kind of do their own thing, which the automotive companies definitely do not like. I could say that much.
I guess that's true, and now I gotta blame Apple too. Wow, okay. You talked earlier about the lunar economy, which is such a cool term, by the way, and it's something that we're gonna have to get used to in our lifetimes, very likely, perhaps even a Mars economy, which would be absolutely incredible, mind-blowing and wonderful and amazing all at the same time. And what you mentioned that with in reference is that there's many companies building many different technologies that will all come together seamlessly, we hope, as NASA builds out the project. One of them will be energy capture. Any thoughts on what that'll be? Will that be solar? Will that be nuclear? Will that be something else?
Yeah, it's a very good question. There's definitely an interest in a lot of different things, like especially solar, but the problem kind of goes back to the dust and dirty conditions, right? What if it builds up on the panels over time? Then it won't be able to capture the sunlight as much as you would like, right? So you
Mhm.
might have to create some interesting geometries then to be able to avoid that situation or at least mitigate it. But for the Viper, for example, the NASA Viper, I believe it has solar panels on the side of it, which helps, but it's not quite enough to keep it going indefinitely, right? So there's likely other kinds of generation solutions. Um, but definitely, I would say solar is, I know, a big interest for sure.
Mhm.
But I've kind of seen interests all over the map. I'm not sure exactly which direction they're going to finalize.
And if you're NASA, you're going to want multiple sources of energy, so you've got redundancy, right? We've all seen Matt Damon in The Martian blowing off his solar panels, right? But there's no atmosphere whatsoever on the moon, so that's a little more challenging. You might have to look at electrostatic solutions or something like that. Who knows? Talk about timetables. What are your timetables for building this, shipping this, and maybe even when it'll get used?
Yeah, yeah. So the first phase of the contract is 6 months. So that's essentially us building it for more like earthbound conditions, but for the performance levels that they're looking for in terms of power and also misalignment. Because the other thing that we have to keep in mind with, right, you can imagine putting your phone on top of the charger in the vehicle. It's not flat on the moon like that.
Yep.
It could be very rocky, very bumpy. You could have a great deal of misalignment or angular misalignments,
Mhm.
right? So the charging station really needs to be able to endure that effectively. So that's a lot of what we're focusing on for phase one. That and using lunar simulants basically of lunar regolith that you could get from some commercial products that are actually off the shelf here to essentially try to simulate those conditions. And then phase two is really getting it ready for lunar conditions in terms
Mhm.
of the radiation exposure, the lunar temperature cycles. Those are very, very big challenges. So that would be phase two. That's typically about 18 months, um, sometimes upwards to 2 years to get that ready. And then at that point, we would ideally like to partner with either a NASA contractor or NASA directly for likely an Artemis mission.
Mhm.
So that way we could get this launched into space, into the moon.
Such an interesting engineering challenge, because not only do you have to build all this and it has to work according to the specifications, conditions that you talked about,
Well,
it also has to be shipped hundreds of thousands of kilometers away. And while costs to launch have come down thanks to SpaceX and almost normalized, right? It used to be what, $10,000 a pound or something like that, a kilogram to get something
mm,
up to space. Maybe it's more like 3,000, 5,000, 1,000, depending. Hopefully, Starship comes around and changes that math again. So you've got to build something that lasts a long time, withstands the radiation, withstands the heat changes, works at various configurations and angles and everything like that, and doesn't weigh very much.
mhm. Yeah, pretty much. So there's a lot of technical, you could say, scrutiny on the development. You really want to make sure it's done right because it's so expensive to send something into space, and we expect that to still be very expensive into the very near future as well. There's a lot of redundancy, to your point, that we actually have to put into the charging station, just in case there's, for example, something unexpected electrically. There's another subsystem that could kick in, right?
Mhm.
Because it's not like going up there and changing a light bulb. It's very, very expensive. It's very, very difficult to fix if there is a problem. Um, so it's interesting technical challenge. We're definitely very well prepared for that challenge, but you almost want to over engineer it to an extent
Mhm.
because of how expensive it is to get there.
And you may have some specs right now for what a lunar rover looks like, feels like, how tall it is, how heavy it is, what surfaces it'll have, and all that stuff. But who knows? Your system might be in operation for 10, 20 years or something like that. And maybe there's a different kind of rover. Maybe there's a
Right.
manned rover. And that's different. And so you want to have something that'll work or at least be retrofittable into different configurations. Super interesting. Are there some terrestrial applications? I've done a lot of shows recently with people who have humanoid robots, bipedal humanoid robots, right? Which are all the rage. We've got Optimus from Tesla, GR1 from a Chinese company. We've got Phoenix from Anthropic, right? Figure.ai. There's Digit. There's so many of these out there. And a core challenge is energy density, right? Some people want to swap battery packs. Some people want to charge them ever so often. So the robot's out of commission for 10%, 20% of the time. Is there a solution here for something like that, perhaps, and or other things terrestrially?
There definitely is. I would say like what we've done with like the National Science Foundation for powering like robotic machinery has been a good transition to this point. There's you could say a lot of applicability for industrial robotics. You could technically go up all the way to vehicles. It's typically not a space commercially that we play in. Not to say it's something that we can't do necessarily in the future. I would say more factory settings and agricultural environments would be very interesting. Um, Things like autonomous tractors, for example,
Mhm,
would be very
mhm,
interesting.
mhm,
Um, that I know, companies like, for example, John Deere are working on.
mhm.
So that would be a very dusty and dirty condition environment, way more so than a factory. That might be very applicable to the kinds of work that we're doing to get it ready for lunar surfaces. But even regular factories, quite frankly, in the US, especially, they could get a little dusty and dirty, especially in automotive factories. So I think there's a lot of applicability there, especially for the power ranges that we're focusing on. It's really about productivity and how we could help enhance productivity.
And then
That's at least how I see it.
absolutely, and the number of robots that we're seeing in US manufacturing is growing massively. Same with logistics, warehouses. A lot of robots of different configurations, sizes, and shapes that are working in manufacturing, but also shipping and packing and all that stuff. So super interesting stuff there. Josh, thank you so much for this time. It was super interesting.
No, I really appreciate it, and thanks for having me.